No, pues,
Bilang
sekarang.
kayaknya satu. Bismillahirrahmanirrahim. Mohon izin Bapak Ibu, acara akan segera kami mulai. Kami informasikan kepada seluruh peserta webinar agar dapat mengerjakan soal pretest melalui tautan yang akan segera kami bagikan. Setelah seluruh materi disampaikan, peserta juga diwajibkan untuk menyelesaikan post-test sebagai salah satu syarat penerbitan sertifikat. Jadi, selain melakukan registrasi, mohon dipastikan Bapak atau Ibu juga menyelesaikan pretest dan post-test dengan baik. Yang terhormat, Direktur Bina Teknik Jalan dan Jembatan, Distinguished Senior Advisor from Business Finland, yang terhormat, para pejabat tinggi Pratama Direktorat Jenderal Bina Marga, yang terhormat, para pejabat administrator Direktorat Jenderal Bina Marga, yang terhormat, para Kepala Balai Besar Pelaksanaan Jalan Nasional Direktorat Jenderal Bina Marga, yang terhormat, para Kepala Balai Pelaksanaan Jalan Nasional Direktorat Jenderal Bina Marga, yang terhormat, para Kepala Balai Teknik Direktorat Jenderal Bina Marga, yang terhormat, para Kepala Satuan Kerja dan PPK Direktorat Jenderal Bina Marga, yang terhormat, Bapak dan Ibu anggota Dewan Pengurus Pusat dan Pengurus Daerah, Asosiasi Profesi Jabatan Fungsional Penata Kelola dan Penata Laksana Jalan dan Jembatan, yang terhormat, para pejabat fungsional penata kelola dan penata laksana jalan dan jembatan, distinguished speakers and moderator, serta Bapak Ibu peserta webinar yang berbahagia. Assalamualaikum warahmatullahi wabarakatuh. Salam sejahtera untuk kita semua. Shalom, Om Swastiastu, Namo Buddhaya, dan salam kebajikan. Selamat siang dan selamat bergabung pada webinar Teknologi AI untuk Deteksi Kerusakan Jalan dan Penerapan Digital Twin dalam Road Management System di Indonesia. Pada hari ini, Selasa 21 Oktober 2025, yang terhubung melalui aplikasi Zoom maupun melalui kanal YouTube. A very good afternoon to everyone, and welcome to our webinar entitled Teknologi AI untuk Deteksi Kerusakan Jalan dan Penerapan Digital Twin dalam Road Management System di Indonesia. This event is being held today, Tuesday, October 21st, 2025, and is accessible via Zoom as well as our official YouTube channel. Apa kabar Bapak Ibu? Semoga Bapak dan Ibu dalam keadaan sehat dan bersemangat dalam menjalankan aktivitas pada siang hari ini. Perkenalkan, saya Iklima, MC yang akan membantu acara kita pada hari ini. Good afternoon, ladies and gentlemen. I hope everyone is doing well and feeling energized this afternoon. It is a pleasure to introduce myself. I am Iklima and I'll be serving as your Master of Ceremony for today's webinar. Bapak Ibu, untuk mengawali kegiatan kita siang hari ini, marilah kita bersama menyanyikan lagu kebangsaan Indonesia Raya dan dilanjutkan dengan Mars PU. Kepada para hadirin, dimohon untuk duduk dengan sikap sempurna. Ladies and gentlemen, to commence our event this afternoon, let us together sing our national anthem Indonesia Raya, followed by the Public Works March. We kindly request all participants to remain seated in attentive and respectful manner. Terima kasih. Thank you. Sebelum memulai kegiatan kita hari ini, marilah kita berdoa menurut agama dan keyakinan kita masing-masing. Berdoa mulai. Before we begin today's program, let us take a moment to pray according to each of our own faiths and beliefs. Let us begin the prayer. Bapak Ibu yang kami hormati, selanjutnya marilah kita simak bersama sambutan yang akan disampaikan oleh Ketua Umum DPP Asosiasi Profesi Jabatan Fungsional Penata Kelola dan Penata Laksana Jalan dan Jembatan. Kepada Bapak Insinyur Ahmad Ghani Ghazali Atman, MNSC, kami persilakan. Ladies and gentlemen, we will now proceed to the opening remarks to be delivered by the Chairman of the Central Board of the Professional Association of Functional Positions in Road and Bridge Management and Operations. It is our honor to invite Mr. Ahmad Ghani Ghazali Atman to kindly deliver his remarks. Mr. Ahmad Ghani Ghazali, the floor is yours.
Baik, terima kasih. Assalamualaikum warahmatullahi wabarakatuh. Selamat siang, menjelang sore, dan salam sejahtera bagi kita semua. Om Swastiastu, Namo Buddhaya, salam kebajikan. Yang saya hormati Direktur Bina Teknik Jalan dan Jembatan Ditjen Bina Marga, Kementerian PU. Pengurus DPP dan DPD Asosiasi Jabatan Fungsional, Penata Kelola dan Penata Laksana Jalan dan Jembatan, para narasumber dan pakar teknologi informasi serta infrastruktur transportasi, rekan-rekan pejabat fungsional penata kelola dan penata laksana jalan dan jembatan di seluruh Indonesia, serta seluruh peserta webinar yang saya banggakan. Puji syukur marilah kita panjatkan kehadirat Tuhan Yang Maha Esa, karena atas rahmat dan karunia-Nya kita dapat berkumpul secara daring dalam acara webinar nasional bertema Teknologi AI Artificial Intelligence untuk deteksi kerusakan jalan dan penerapan digital twin dalam road management system di Indonesia. Bapak Ibu yang saya hormati, sebagaimana yang kita ketahui, jalan merupakan salah satu infrastruktur utama yang menopang kegiatan ekonomi dan sosial masyarakat. Namun kondisi jalan di berbagai daerah di Indonesia masih menghadapi tantangan besar, mulai dari kerusakan dini, keterbatasan sumber daya dalam inspeksi lapangan, hingga kurangnya data yang akurat dan terintegrasi dalam pengelolaan aset jalan. Dalam konteks inilah pemanfaatan teknologi artificial intelligence atau AI dan konsep digital twin menjadi langkah strategis yang sangat relevan, di mana teknologi AI memungkinkan proses deteksi kerusakan jalan secara cepat, objektif, dan efisien. Sementara digital twin menghadirkan replika digital dari jaringan jalan yang memungkinkan pemantauan dan pengambilan keputusan berbasis data secara real time. Melalui acara webinar ini, kami ingin membangun pemahaman dan kapasitas para pengelola, penata kelola, serta penata laksana jalan dan jembatan agar mampu beradaptasi dengan perkembangan teknologi sekaligus menerapkannya dalam tugas sehari-hari. Asosiasi PKPL JJ berkomitmen untuk terus menjadi wadah pengembangan kompetensi dan pertukaran pengetahuan atas profesional, mendorong penerapan teknologi terkini dalam penerapan teknis di lapangan, dan memastikan bahwa transformasi digital di bidang jalan tidak hanya sebatas inovasi teknologi, tetapi juga berdampak nyata bagi peningkatan pelayanan publik dan keselamatan pengguna jalan. Kami berharap kegiatan ini dapat menjadi momentum penting untuk mempercepat transformasi digital dalam manajemen jalan di Indonesia, serta memperkuat kolaborasi lintas sektoral dalam mewujudkan infrastruktur yang cerdas, tangguh, dan berkelanjutan. Akhirul kata, saya menyampaikan apresiasi dan terima kasih kepada seluruh panitia, narasumber, serta peserta atas partisipasi aktif. Semoga kegiatan ini membawa manfaat nyata dan menginspirasi langkah-langkah inovatif bagi kemajuan jabatan fungsional kita dan pembangunan infrastruktur Indonesia. Demikian yang dapat saya sampaikan. Wabillahi taufiq wal hidayah. Wassalamualaikum warahmatullahi wabarakatuh. Saya kembalikan. Terima kasih.
Terima kasih Bapak Ahmad Gani Ghazali atas sambutannya. Thank you very much, Mr. Ahmad Gani Ghazali, for your insightful and encouraging remarks. Bapak Ibu yang kami hormati, selanjutnya, marilah kita simak bersama sambutan yang akan disampaikan oleh Senior Advisor Business Finland. Kepada Ibu Priscilla Maria, kami persilakan. Ladies and gentlemen, we will proceed to the opening remarks to be delivered by the Senior Advisor of Business Finland. It is our honor to invite Ms. Priscilla Maria to kindly deliver her remarks. Ms. Priscilla, the floor is yours.
Thank you, Mbak. Okay, greetings from Business Finland. First of all, please let me introduce myself. I'm Priscilla, a Senior Advisor of Business Finland, or a commercial arm of the Embassy of Finland. On behalf of Business Finland, I'd like to thank you to the Ministry of Public Works, particularly to the Directorate of Road and Bridge Engineering Development, which represented by Pak Panca Dharma Utoyo as a director, and the gratitude also goes to his team and also to the association. We feel honored to share our knowledge, expertise, and best practice regarding AI technology and the implementation of AI in daily life, in this case to detect the road damages. Finland is one of the leading countries for AI technology and was among the first countries to launch an artificial intelligence program in 2017, which aims to support the national AI strategy. Since then, all stakeholders, including companies, researchers, public sector, academia, have collaborated to develop AI technology and leverage it in everyday life. Today, we have 3 experts from Finland who could share their expertise and knowledge in developing AI technology and its implementation. I hope today's session will bring a lot of benefit to you all and can take Finland experience and expertise to your learning and guidance for the ministry plan to use AI technology in completing the importing task. Thank you.
Terima kasih Bu Priscilla Maria atas sambutannya. Thank you very much Ms. Priscilla Maria for your insightful and encouraging remarks. Bapak Ibu yang kami hormati, selanjutnya marilah kita simak bersama arahan yang akan disampaikan oleh Direktur Bina Teknik Jalan dan Jembatan yang sekaligus membuka acara pada siang hari ini. Kepada Bapak Insinyur Panja Dharma Utojo MSc, kami persilakan. Ladies and gentlemen, we will now proceed to the remarks and opening address to be delivered by the Director for Road and Bridge Engineering Development. It is a great honor to invite Mr. Panja Dharma Utojo to kindly deliver his address and officially inaugurate today's event. Mr. Panja Dharma Utojo, the floor is yours.
Terima kasih Pak Iklima. Bapak Ibu sekalian, Assalamualaikum warahmatullahi wabarakatuh. Selamat siang dan salam sejahtera untuk kita semua. Salam, Om Swastiastu, Namo Buddhaya, dan salam kebajikan. Yang saya hormati Bapak Ketua Umum DPP Asosiasi Jabatan Fungsional, Penata Kelola dan Penata Laksana Jalan dan Jembatan. Yang saya hormati Bapak-Bapak, Ibu, para narasumber webinar kita hari ini. Yang kami hormati Ibu Priscilla dari Bisnis Finland. Yang saya hormati Bapak, Ibu, seluruh peserta webinar, para Japung, para Kasubdit, Kepala Balai. Pertama-tama, marilah kita panjatkan puji syukur kehadirat Tuhan Yang Maha Esa. Karena atas rahmat dan karunia-Nya, kita bisa menyelenggarakan dan hadir bersama-sama dalam acara webinar teknologi Artificial Intelligence untuk deteksi kerusakan jalan dan penerapan digital twin dalam road management system di Indonesia. Bapak Ibu, hadirin yang saya hormati, kita memiliki tantangan yang cukup besar dengan panjang jaringan jalan lebih dari 500.000 kilometer. Kita menghadapi berbagai kondisi jalan. Tentunya akan membutuhkan data atau informasi dari kondisi jalan yang akurat, terkini, dan juga sekaligus terstandarisasi, sehingga kita bisa buat suatu kebijakan, perencanaan, pemrograman, dan juga penanganan jalan tersebut. Dalam konteks inilah pemanfaatan teknologi digital, khususnya artificial intelligence dan digital twin, menjadi peluang besar untuk kita bersama-sama mentransformasi cara-cara kita dalam mengelola aset infrastruktur jalan dan jembatan. Teknologi AI kini telah mampu melakukan deteksi kerusakan jalan secara otomatis melalui citra dan video, sekaligus memberikan hasil analisis yang cepat dan objektif, serta dapat mendukung pengambilan keputusan yang berbasis data. Sementara itu, digital twin juga mampu untuk memberikan dan menghadirkan replika digital dari kondisi nyata jalan dan jembatan, yang memungkinkan kita bisa melakukan pemantauan, analisis, hingga simulasi secara real time, sesuatu yang sebelumnya sulit kita bayangkan dalam manajemen aset infrastruktur. Namun demikian, kita juga menyadari bahwa penerapan teknologi ini di Indonesia masih menghadapi sejumlah tantangan, terutama dalam aspek standarisasi, validasi data, serta penerimaan hasil analisa artificial intelligence agar dapat diakui secara resmi dalam proses pengambilan keputusan. Kita tentunya memerlukan pedoman-pedoman yang secara nasional bisa kita develop bersama, standarisasi data, serta sistem validasi yang transparan, agar hasil kerja artificial intelligence ini dapat dipercaya dan dimanfaatkan dalam kegiatan kita mengelola jaringan jalan. Bapak Ibu hadirin yang saya hormati, kegiatan webinar hari ini menjadi sangat penting karena melalui forum ini kita akan memperoleh pembelajaran langsung dari pengalaman Finlandia, salah satu negara yang telah berhasil menerapkan AI dan digital twin dalam sistem manajemen jalan mereka. Kami tentunya berharap melalui diskusi dan pertukaran pengetahuan ini kita dapat memperoleh wawasan mengenai best practice internasional sekaligus merumuskan langkah-langkah konkret untuk memperkuat penerapan teknologi serupa di Indonesia. Kami juga berharap kolaborasi antara Indonesia dan Finlandia ini dapat terus berlanjut, tidak hanya pada tingkat pertukaran pengetahuan, tapi juga dalam bentuk kerjasama riset, pengembangan standar, dan integrasi sistem teknologi yang dapat diterapkan di lingkungan Kementerian Pekerjaan Umum dan pemerintah daerah. Sebagai penutup, saya ingin menyampaikan apresiasi dan terima kasih yang sebesar-besarnya kepada seluruh pihak yang telah berkontribusi dalam penyelenggaraan webinar ini. Semoga kegiatan kita bersama pada hari ini memberikan manfaat nyata bagi peningkatan efisiensi, transparansi, dan akurasi dalam manajemen jalan dan jembatan di Indonesia. Demikian yang dapat saya sampaikan. Sekali lagi kami ucapkan terima kasih atas perhatian dan partisipasi Bapak Ibu sekalian. Wabillahi taufiq wal hidayah. Wassalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh. Terima kasih atas kesediaan Bapak Panca yang telah menyampaikan sambutan sekaligus membuka kegiatan kita hari ini. We would like to express our sincere appreciation to Mr. Panca Dharma Utojo for his valuable remarks and for officially opening today's program. Bapak Ibu sekalian yang saya hormati, sebelum mulai pada acara inti, untuk mengabadikan momen kita hari ini, kami mengundang Bapak Direktur, Bapak Ketua Asosiasi, Ibu Senior Advisor Business dan Land, Bapak narasumber dan moderator, serta Bapak dan Ibu peserta untuk melakukan foto bersama. Bapak dan Ibu diharapkan untuk mengaktifkan kamera dan akan saya pandu. Kita akan mengambil 3 kali pengambilan foto. Ladies and gentlemen, before we proceed to the main session, let us take a moment to capture this special occasion. We would like to invite the director, the chairman of the association, senior advisor of business and land, our distinguished speakers and moderator, as well as all participants to join us for a group photo. We kindly request everyone to turn on their cameras for a moment. I will guide you through the photo session and we will take 3 shots together. Baik, let's get started. 1, 2, 1, 2. Second shot, gaya mengepal atau chest raising pose like this, seperti ini. Ya, ya. 1, 2, 3. Okay, maybe that's all. Thank you. Terima kasih semuanya Bapak Ibu. Bapak Ibu yang kami hormati, kita akan segera memasuki sesi utama, yaitu paparan dengan materi yang pertama, yaitu Navigating the Challenge of AI Technology in Indonesia, yang akan disampaikan oleh narasumber kita, Bapak Firman Permana Wandani, STMPP. Dilanjutkan dengan materi kedua, yaitu Finish Data Driven Transport System Leveraging Emerging Technologies, dengan narasumber kita, Bapak Kimo Lisirunen. Dilanjutkan dengan materi ketiga, yaitu Digital Monitoring for Road Network dengan narasumber kita, Bapak Oli Tanner Koski. Dan materi keempat, yaitu Automated Road Surface and Digital Twins dengan narasumber kita, Bapak Imo Sarenta. Ladies and gentlemen, we will now proceed to the main session, which will feature a series of presentations. The first presentation, titled Navigating the Challenge of AI Technology in Indonesia, will be delivered by Mr. Firman Permana Wandani. The second presentation, Finish Data Driven Transport System Leveraging Emerging Technologies, will be presented by Mr. Kimo Lisirunen. Next, the third presentation, Digital Monitoring for Road Network, will be delivered by Mr. Oli Tanerkoski. And finally, the fourth presentation, Automated Road Surface and Digital Twins, will be presented by Mr. Timo Sarenpa. Acara akan dilanjutkan dengan diskusi yang dipandu oleh moderator kita, Bapak Vito Berkat Harahap, ST MPWK MMG. Berikut adalah profil dari narasumber dan moderator kita hari ini. Following these presentations, we will have a discussion session, which will be moderated by Mr. Vito Berkat Harahap. Now, let's us take a look at the profiles of our distinguished speakers and moderator. Berikut profil moderator kita, Bapak Vito Borkat Harahap. Beliau menempuh pendidikan S2 di Keio University dan Institut Teknologi Bandung pada tahun 2019. Lalu S1 beliau ditempuh di Institut Teknologi Bandung pada tahun 2010. Riwayat pekerjaan beliau ialah menjadi penata kelola jalan dan jembatan ahli muda di bawah Direktorat Bina Teknik Jalan dan Jembatan dari tahun 2020 sampai dengan sekarang. Pada tahun 2023 sampai dengan 2024, beliau menjabat sebagai Ketua Tim dan Data dan Informasi pada Subdirektorat Data dan Sistem Informasi Jalan dan Jembatan. Baiklah, selanjutnya acara kami serahkan kepada Bapak Moderator. Kepada Bapak Vito Borkat Harahap, kami persilahkan. Well then, ladies and gentlemen, we will now hand over the session to our moderator. It is our pleasure to invite Mr. Vito Borkat Harahap to kindly lead and moderate the next session. Mr. Vito, the floor is yours.
Baik, terima kasih Bu Iklima. Assalamualaikum warahmatullahi wabarakatuh. Selamat siang dan salam kenal Bapak Ibu sekalian. Mungkin izin cek suara saya terdengar, Bu Iklima?
Dengar Bapak.
Dengar ya, siap. Selamat siang dan salam kenal Bapak Ibu sekalian. Izin Pak Dirbintek, para pengurus dan anggota Asosiasi Profesi Jabatan Fungsional, penata kelola dan penata laksana jalan jembatan, dan para peserta webinar di siang hari ini. Thank you for all the invited speakers from Finlandia. Thank you for joining us. And please allow me to speak mostly in Indonesian since our audience mainly is from Indonesia. Selamat siang Bapak Firman Permanawandani dan para speaker dari Finlandia. Good afternoon Pak Kimmo Ulisyurunen, Pak Oli Tanarkoski, Pak Timo Sarenpa. Please forgive my pronunciations. Masing-masing speaker izin kita coba alokasikan waktu untuk sharing selama 20 menit. Sedangkan untuk waktu diskusi dan tanya jawab akan kita lakukan di akhir dari speaker keempat. So for the speakers, we allocate 20 minutes for each speakers to share their knowledge. And for the Q&A sessions, will be at the end of the fourth speakers. And please allow me to make a reminder when you have 5 minutes left. So without further ado, for the first speaker we have, mungkin izin boleh di share screen CV Pak Firman. Baik, Bapak Ibu, untuk pembicara pertama ada Pak Firman Permanawandani, STMPP. Beliau akan menyampaikan tentang Navigating the Challenges of AI Technology in Indonesia, jadi tantangan penggunaan AI di Indonesia. Beliau memiliki education background di 2014 Master of Public Policy dari GRIPS Tokyo ya. Lalu 2004 Teknik Planologi ITB. Lalu pengalaman pekerjaan beliau saat ini dari 2023 sampai saat ini sebagai Kasubdit Data dan Sistem Informasi di Bintek Jatan. Lalu sebelumnya sebagai Kasatkar PJN 1 Banten dan sebelumnya lagi sebagai Kasatkar PDJN Babel. Nah, mungkin waktu dan share screen kami persilakan Pak Firman 20 menit. Mangga Bapak.
Oke, terima kasih Pak. Jadi sorry. Oke, sudah kelihatan?
Sudah terlihat Pak. Mungkin kalau boleh di full screen, izin Pak.
Oke. Sorry, agak delay. Terima kasih kepada semuanya. Assalamualaikum warahmatullahi wabarakatuh. Mungkin di sesi ini saya coba mix ya, mungkin ada kadang bahasa Inggris, kadang bahasa Indonesia, karena sebagian besar ini audiensnya dari Indonesia, tapi kita juga ingin memberikan beberapa informasi kepada teman-teman Finlandia. So, in this session, I will speak mix, maybe Indonesian and some in English, because most audience in Indonesian. But I also want to give information to my friend from Finland. So, ini adalah target kita, ini kondisi jalan kita, ini aset kita. Jadi panjang jalan kita ini sekitar 47.000. Ini tersebar di seluruh Indonesia. Jembatan 563.000 dan jalan nasional sekitar 47.000. So our asset bridges is the first round of the island is about 500,000, and our national roads for non-toll is 47,000 and toll road around about 2,000. But it's only small part of our asset. The biggest part is in provincial road is about 48,000 and Regency is 4,000 kilometers. So 4,000 kilometers, 400,000 kilometers. So we have asset about 500,000 kilometers of road dispersed from around the country. Kita punya target. We have a target that's in our strategic planning that we should improving the performance of road connectivity infrastructure service and improving the quality of governance within the Ministry of Public Works. That's our goals in 2025 to 2029. Jadi ini target range lah, ini draft range lah. Jadi kita semua kegiatan di Bina Marga ditujukan untuk konektivitas dan juga memperbaiki good governance terkait bidang jalan tentunya. Jadi di support, salah satunya kita berharap ada supporting dari teknologi yang kita harapkan kita akan gunakan, yaitu AI and digital twin. Di kita ini mungkin sudah yang di bidang jalan sudah sering mendengar kita tentang SID Lakom. Jadi mulai dari planning sampai ke operation maintenance. Jadi di sini kita bicara tentang digitalisasi. Jadi sebelum kita bicara tentang AI, bicara digital twin, kita bicara tentang digitalisasi itu sendiri. Jadi memang saat ini kita sedang proses mendigitalisasi seluruh proses ini, mulai dari perencanaan sampai ke OM. So in Indonesia, we are in the phase try to digitalize our asset, our business process from planning to operation maintenance. We hope that using AI and digital twin will be ease our process into digitalization our asset from the planning to the operation maintenance. The current condition in our road sector, we have asset Indonesia total road is about 541,000 kilometers of road that need maintenance. However, our road condition, especially for district city road, the good and fair position is only in 63%. So on other hand, that we can say that almost more than 30% of our network in very poor and bad condition. Jadi saat ini PR kita banyak di jalan daerah. Nah, untuk jalan nasional itu sudah kita mencapai 90% lebih, tapi secara keseluruhan jalan kita masih kondisi baik dan sedang itu di 63%. Kita juga punya isu that our cost to maintenance is higher than average in international range. So our maintenance cost is about 37% higher than in international range. Jadi kita berharap ini bisa kita turunkan dalam beberapa tahun ke depan. Lalu apa gambarannya tentang digitalisasi dan AI adoption di bidang jalan dan jembatan? Jadi Bapak Ibu, AI ini di bidang kita ini agak terlambat di bidang lain. So digitalization in construction is relatively lower than in manufacturing, healthcare, or logistics. Jadi kalau terutama di kita ya, kalau Ibu Bapak ke lapangan pasti masih numpuk kertas kalau ke kantor-kantor, kantor proyek atau di kantor kita sendiri. Ini menunjukkan bahwa digitalisasi proses di bidang konstruksi ini relatif lebih lambat daripada yang lain. Jadi begitu juga dengan AI. AI adopsi di bidang konstruksi secara umum itu jauh tertinggal dibandingkan bidang-bidang lain. So I want to say that digitalization is lower and much left behind compared to manufacturing, healthcare, or logistics. Also, the AI adoption in infrastructure quite still limited compared to other sectors. There is no official international guideline for AI use in infrastructure in this current situation. But we have difficulty to find best practice also in foreign countries. We have problem to seek reference for regulation about using AI in road sector. It's very limited even I check in Europe or in US itself. Jadi memang bukan hanya kita Bapak Ibu yang tertinggal di AI ini. Jadi sebagian besar di sektor jalan ini agak tertinggal. Bahkan ketika kami mencari referensi gitu ya, dokumen-dokumen referensi itu dari Amerika, dari Eropa itu susah sekali untuk menemukan referensi tentang pemanfaatan AI di bidang jalan dan jembatan. Meskipun ada, sifatnya masih terbatas gitu dan agak susah diimplementasikan di kita di Indonesia. Tapi, however, the trend is increasing from 2019 to 2024, so the trend is good. But however, it's happened in foreign country. In Indonesia itself, we still lag behind about investment in AI or in digital twin right now. So di beberapa negara yang leading saat ini di bidang infrastruktur menggunakan AI itu sebagian besar masih di negara-negara maju dan kita masih tertinggal gitu ya Bapak Ibu, dan ini yang kita usahakan untuk kita mengejar. So Indonesia is still behind, but we are still struggle to catch up about to utilize AI and digital twin for construction. Dan kita sudah mulai ini sejak 2022-2023 untuk mulai ke era AI dan mempersiapkan diri AI dan digital construction. Jadi sebenarnya AI ini banyak potensinya kalau kita bisa memanfaatkannya dengan baik. Jadi AI ini bisa kita gunakan mulai dari tahap planning dan desain. AI bisa bantu kita mendesain lebih baik, lebih efisien. Juga untuk konstruksi dan supervisi. Jadi untuk laporan progres, untuk keamanan, itu AI cukup baik. Seperti dia memonitoring keselamatan di site, melaporkan progres, itu juga mereka bisa kita manfaatkan. Lalu untuk di survei ini kita juga bisa menggunakan untuk meriksa kerusakan, untuk forecasting, dan untuk lalu kita juga bisa menggunakan ini misalnya untuk HMS. Kita bisa mengecek anomali dan kerusakan. Juga kita bisa menggunakan digital twin untuk simulasi. Nah, itu juga kita bisa menggunakan AI itu untuk mendeteksi analisa makro. Contohnya itu analisa makro itu untuk mendeteksi kawasan rawan bencana. Jadi potensinya itu sangat besar untuk di bidang jalan jembatan. Namun ternyata itu tidak semudah ya kita lakukan. Jadi potensinya ada, tapi kita punya hambatan. Saya rasa di Indonesia, tidak hanya di Indonesia, di negara lain pun sama ada hambatannya. So we have problem to implement AI. There are technical barriers. Firstly is that most data is remain unstructured. Jadi data kita ini unstructured, kebanyakan PDF. Satu lagi data kita itu tidak standar. Banyak data-data kayak data-data di lapangan itu laporannya itu tidak standar dan tersimpan dalam PDF. Ini menyebabkan di satu sisi AI itu perlu banyak training set. Jadi satu, kita ini datanya unstructured, di satu sisi itu kita perlu dataset yang banyak. So we have difficulty in AI and digital twin that our current situation that most of data is unstructured and unstandardized data. But AI itself did reach of data set. Because of this condition, the lack of data, it is difficult to us to create a large and high quality training data set. Terus, we have difficulty also that in infrastructure project, the construction, we do in outdoor environment. In that outdoor environment, there are also a lot of variable that uncontrolled, such as weather, lightning, the different of materials. Jadi kalau kita using mesin vision, kita tuh ada masalah di AI ini. Salah satunya itu kita tuh di outdoor. Di outdoor ini lebih sulit menerapkan AI karena banyak hal yang tidak bisa kita kontrol. Lalu model yang ada saat ini seringkali cocok untuk di lokasi tertentu, belum tentu cocok di lokasi lain. Jadi modelnya itu fail to generalize. Gitu. Ini yang sering jadi masalah. Misalnya kita training set di Pantura model, itu akan cocok buat di Pantura. Ini contoh buat AI kerusakan ini. Ketika kita coba di tempat lain, itu kurang drop kualitasnya. So AI for road detection, damage, sometimes it's good for certain location but it could be fail in other locations. So for example, it's very good in some country, and if we try another model in other country, it goes fall, and that's a big issue using AI for road detection, for example. So selain itu juga kita ini ada masalah. Jadi ini masalah memang hambatan kultural bahwa saya lihat di dunia konstruksi ini masih menyukai hal-hal yang manual dan agak sulit menerima perubahan yang ketika perkenalkan hal yang baru itu tidak mudah untuk dapat dilakukan. Ini yang menjadi hambatan kita untuk digitalisasi. Itu juga masalah literasi tentang digital maupun AI masih belum banyak, masih terbatas di engineer kita. Selanjutnya juga ada regulasi yang belum terlalu jelas di infrastruktur. Dan ini selain itu juga di AI ini ada masalah black box. Jadi kalau kita menggunakan AI, itu ada isu black box. Jadi kan AI itu model yang dibangun sendiri yang kita nggak bisa verifikasi. Yang kita bisa lakukan itu training, tapi kita nggak bisa memverifikasi ke dalam pemodelannya seperti apa. Ini akan menjadi isu audit dalam terutama untuk proyek-proyek pemerintah. Lalu apa yang perlu dilakukan? eh, yang kita lakukan untuk bisa mengoptimalkan pemanfaatan AI di bidang jalan dan jembatan. Jadi yang ke satu itu tentunya meningkatkan digital literasi dan training, membuat policy tentang open data, ada kolaboratif ekosistem antara akademi, industri, dan pemerintah. Lalu juga tentunya ada melakukan validasi model terhadap dunia nyata. Jadi apa yang harus kita lakukan, ini yang perlu kita lakukan terus-menerus, yaitu memperkuat digitalisasi. Jadi tadi AI itu perlu data training. Data training berarti perlu data. Data datang dari mana? Dari proses digitalisasi. Jadi semua proses digitalisasi, dikonstruksi, mulai dari perencanaan sampai pemeliharaan, harus kita rekam dalam bentuk digital. Begitu juga data-data itu harus terstandarisasi. Tapi memang tadi untuk di sektor konstruksi tidak semudah manufaktur karena konstruksi ini bukan sistemnya kayak manufaktur yang replicable, berlaku di A bisa berlaku di B bisa berlaku di C. Kalau infrastruktur ini konsepnya project. Kalau konsep project satu lokasi dengan konsep lain itu bisa unik masalahnya. Ketika masalah itu unik berarti variabelnya itu banyak. Kalau variabel banyak untuk AI perlu lebih banyak data. Nah, ini jadi masalah, data kita nggak tersedia. Lalu kita juga butuh menentukan aturan, dan ini yang penting, eh, pemerintah harus masuk di sini untuk menyediakan training dataset. Ini banyak di negara lain, dataset training ini disediakan oleh pemerintah. Kita bisa download data training set dari Amerika, data training set dari eh, Jepang, misalnya, itu bisa diakses oleh publik untuk eh, sistem yang dibangun oleh pihak di ketiga. Jadi dia nggak punya data set yang sifatnya itu public domain. Lalu perlu kerjasama dengan negara lain yang sudah berpengalaman. Ini adalah salah satunya dengan Finlandia yang salah satunya berpengalaman. Juga memperkuat kapasitas building dan awareness di dalam negeri. So Indonesia
Firman,
try
izin,
to, okay,
waktunya 4 menit lagi mungkin, izin Bapak.
yeah. So that in Indonesia we try to utilize AI and digital tool in Indonesia. We have several strategies. First, accelerate digitalization. Second, standardize the core process, develop AI guideline, build national training data set, especially for multi-image, foster this domestic international collaboration, and strengthen capacity building and awareness. So we hope that with that strategy, we can achieve 4 things. That we build a national raw data AI data set that standardized and open to public, establish a governance auditing framework for public infrastructure, promote pilot project integrating digital twin AI across regional office, AI enhance decision making to replace human expertise. Jadi visi kita ini AI is not to replace human, but making AI help us as a tools to make better decision and strategies. Salah satu contoh pemanfaatan AI yang mungkin nanti akan dibahas teman-teman Finlandia itu adalah penggunaan AI untuk pendeteksian kerusakan. Jadi saat ini kalau kita menggunakan secara manual, itu waktunya itu lama, jadi kita perlu pendekatan baru sehingga kita lebih cepat juga hasilnya lebih terpercaya gitu ya. Kita membutuhkan itu. Namun kita punya beberapa hambatan untuk pendeteksian kerusakan ini. Jadi yang pertama ini kita ingin suatu sistem yang dapat mengukur kerusakan dan jenis kerusakan menggunakan AI. Nah, ini yang jadi masalah. Sebagian besar kita melihat sistem yang ada saat ini, dia sangat sensitif. Artinya, ketika dia dicoba di lokasi lain atau di tempat lain, di negara lain, di luar dia di training, itu biasanya akurasinya ngedrop. So we have problem that the current system that we have tried is good in the ideal settings or in their countries, but it's fail into sufficient accuracy when we try in another location. So factors such as lighting, shadow, vehicle interference, surface texture, camera quality is big issue. To get that, to solve the issue, we need build more and more high quality data set for training. Jadi Bapak Ibu, penggunaan ini kami lihat setelah kami evaluasi, ini sangat-sangat bergantung kepada banyak faktor yang di luar kontrol. Karena kita kan di luar di lingkungan outdoor ya. Cahaya beda sedikit, terus tekstur kan di aspal ini teksturnya nggak sama tiap daerah, apalagi nggak bicara negara. Teksturnya beda, terus di situ ada kendaraan lewat dan nggak ada kendaraan lewat di sampingnya, ini sangat mempengaruhi kemampuan juga mendeteksi. Jadi untuk saat ini isu terbesar kita adalah di akurasi ini dia cukup kuat kalau di training di lokasi tersebut. Dan ketika coba di lokasi yang agak lain itu akan drop akurasi dan lainnya. Untuk mencapai akurasi yang bagus, artinya apa? Kita harus men-training si sistem dengan berbagai variabel faktor yang berbeda. Inilah yang kita bilang perlu dataset yang banyak. Ini tidak berlaku hanya untuk AI kerusakan, tapi seluruh AI. Nanti ke depannya kalau kita mau pakai AI apapun itu ya, kita memerlukan data training yang bagus. Nah, hasilnya itu sangat bergantung ke data training. Masalahnya di Indonesia itu klasik kita ini kesulitan mendapatkan data yang bagus. Ketika kita kesulitan membangun data yang bagus, kita kesulitan membangun sistem AI yang handal. So we have problem that AI is very depend on the training, and the training is depend on the data. Indonesia have big issue about data quality and data quality and data itself. We don't have adequate good data in our system, so we are struggling to use AI and develop AI for construction, especially in road and bridge, and also in maintenance. Also, we have issue on that. So why our strategy is to digitalization and to capture data as much as possible, and it will be a good start for utilization AI and digital tool in the future. Itu yang dapat saya sampaikan. Terima kasih. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh. Terima kasih banyak Pak Firman. Tadi lebih dikit nggak apa-apa Pak. Jadi mungkin izin menyimpulkan sedikit Bapak Ibu. Tadi disampaikan terakhir oleh Pak Firman, good AI butuh a lot of training datasets gitu ya. Cuman isunya adalah di data kita sendiri dari sisi quality sama quantity-nya itu juga masih kurang. Jadi tadi ada barrier yang disampaikan, data kita tuh banyak bentuknya PDF, dan nggak standar, jadi susah untuk buat dataset. Lalu ada isu kultural gitu ya, dunia konstruksi kita masih suka yang manual, dan ada isu black box dari model AI. Jadi itu akan sulit untuk diverifikasi, yang nantinya kalau untuk proyek pemerintah itu jadi isu pada saat audit ya. Jadi strateginya tadi yang disampaikan, dataset itu harus disediakan pemerintah untuk jadi data training ya. Jadi perlu dibuat AI governance dan standarnya perlu dibuat. Dan tujuan akhir itu to make AI to help human making decision and strategy. Nah mungkin a lot of barrier and issue and challenges that explained by Pak Firman, maybe it can be answered for by all of the next 3 speakers. So thank you Pak Firman. Let me introduce for the second speaker. Mungkin kalau boleh di-share CV-nya. Terima kasih Bu Laras. So for the second speaker, we will have Pak Kimo Ulisyurunen. He will explain and sharing his knowledge regarding Finnish data-driven transport system, leveraging emerging technologies. So he has an education background in 2000 as a Master of Science in Transport and Logistics from Tampere University of Technology. And he has experience now currently as a head of cluster for traffic data service cluster, Fin traffic company. And for the previous 2 years, he is a business development manager in Ramboll, Finland. And before he became a CEO in Info Tripla Limited from 2003 until 2021. So without further ado, Pak Kimo, the time and the screen is yours. Please, Pak.
Thank you. Just to make sure that my voice is heard.
Yes, yeah, we can hear you.
Good. And now most likely my screen is also there.
Yes, Pak.
Over there. So you have it in presentation mode, am I right?
Not yet. We are still seeing your slide version.
Oh.
Still showing the user view.
What about now?
Working now.
Okay, thank you very much. And first of all, would like to say my best thanks related to this great honor to participate to this important webinar you have related to these emerging technologies. I already saw a lot of similarities, a lot of similar challenges related to these things during the presentation we just heard. And thank you for having us here from Finland, all of us, and sharing our experiences and information. This is a very good opportunity to share information and also to learn from others. So my name is Kimmo Yliseuron. I'm coming from a company called FinTraffic. I will share some information about FinTraffic in a minute. But I'm today here to share some information about Finnish data-driven transport system and especially related to these topics we have here today related to emerging technologies and how we are using those. I have 20 minutes, so a lot of information, but not too much. So we can continue afterwards if any questions comes during the presentation. But first, start shortly about FinTraffic. I would like to say that we are quite unique in traffic management because our role as a FinTraffic is to manage the traffic in order to provide smart services for the safest, smoothest, and most environmental friendly traffic in the world. And what is unique here? Unique here is that we are including all traffic modes under the same roof. So something like 6 years ago, our government decided to take all the traffic management, traffic data related functionalities and traffic management under to the same roof, and they established a company called FinTraffic. So we are 100% state-owned company. Our responsible is to manage the traffic on railways, on air, on roads, and also related to maritime. So we have more than 500,000 trains each year. We have something like 22 airports at the moment. And most of our 78,000 kilometers road networks are carrying 90% of passengers transport in Finland, and more than 120 million kilometers driven in vehicles every day. And also, if you look at the map, you can see that our really crucial way, for example, for logistics is based on the maritime traffic, because we are in the north from Europe. So most of the exports and most of the goods are traveling by ferries and vessels. So this is the situation. Why we are quite unique. We are cooperating with all traffic modes at the same time. And what is here, the crucial part is down there. All these functionalities related to traffic management and operations we are doing are based on real-time situational awareness. So the data is really in a crucial role, whatever we do at FinTraffic. So as today, the topic was mostly related to the roads. So I'm not going through about the other traffic modes over there. If you are interested about those, we can easily provide more information related to those. But today I'm concentrating on digital monitoring of roads for smooth and safe traffic in order to provide information exactly related to the topic of today's webinar. So to start with a little bit old picture, it's not like that anymore. It's a much modern way nowadays. But just to introduce what is the backbone of traffic management in Finland, it's of course road traffic management centers, which are open 24 hours a day. And what is here especially important related to the data is that, as you can imagine, you can see Finland over there. We only have 3 offices where we have FinTraffic road traffic management centers. Southern part of Finland, of course, most of the people are living in the southern part of Finland, but we have to control, we have to manage all the traffic on all those roads coming from southern part to the northern part, and the distance over there is something like 1,400 kilometers. So this is only about we can only make this on a help of using a data quite clever way. What that means that we have lots of people working for traffic management. We have lots of traffic paladins. We have lots of calls, lots of messages between our services and the users over there. But we cannot do that without good monitoring systems. So that's why there are lots of VSLs, VMSS, there are road weather stations, there are lots of cameras which are controlling the weather conditions and traffic. And there are also monitoring stations, there are traffic lights, there's automatic traffic surveillance stations. As we already heard that you also have some challenges related to weather in these new technologies. You can imagine we also have some challenges with those weather conditions, because something like 6 months per year, the northern part of Finland is purely covered by snow and ice. So we also have some challenges where we have to learn doing and learn using the new technologies in all conditions. But we are quite good on that. We have a lot of experiences already, and it's like always there. So what we do, the traffic management on roads. So of course we have open road sections. We have lots of tunnels at the moment. We have road weather conditions. We have to monitor. We have to monitor also the automatic traffic surveillance and border crossing points. And we are using traffic measurements a lot in order to provide the crucial information, crucial data in order to make these traffic operations. And also in some part of the network, we also have traffic lights. The reason why I'm saying in some part of the network is that as we are the national operator for this traffic management, we are not covering the city roads. So the cities are covering the roads, and most of the traffic lights are, of course, next to the city roads. That's why we only have a few of them. And as a result, based on the information and based on all the operations, the final goal is, of course, that we know what is happening on our roads, and especially crucial what will happen on our roads. You can imagine when we are combining different kind of data sources, we can then predict the conditions, what happens there. We can also predict what happens with the traffic and which kind of challenges we are facing every time. And by combining also the traffic information to this part, traffic signals, signs, and whatever, we can inform the users and then predict the traffic hazardous situations on our roads. And this is quite busy slide. This is something which gives us an overview about what this means from our operations point of view and using a data point of view. Down there is a traffic management and control services for all traffic modes. So there is a lot of need of data aggregation, cleansing, and enrichment based on the data we collect from different sources. And this goes to our digital ecosystem services, which is using ecosystem data platforms for different purposes and orchestration of this ecosystem in order to provide digital end user services. I would like to highlight, which also you can realize after my presentation, there are company presentations, because as we are a government-owned company, we are not doing these things by ourselves. Of course, we are using lots of services. We are using lots of companies, lots of stakeholders and partners in order to provide these systems and services. But the crucial point is that we have lots of this kind of good companies, like today we hear two of those, which are providing excellent solutions we can use in order to achieve the targets and objectives we have for the traffic management. So at the end, based on these layers, we are providing digital end user services for different kind of user groups, starting from traffic operators and citizens, ending up to services for companies and services for authorities. And we would like to see that, and we are doing a lot of work in order to provide sort of circular services, meaning that whatever we do to the upper level and provide services, those services will also bring us more information in order to use as a material and new material for even better services. So this is like a circle of data. Whatever is bring to the users, we can get the feedback from users or service providers, and then we can enrich all the time the system we have for the traffic management. And if we think about the AI at FinTraffic, this is one of the topics we have today. So I picked up some examples, and as I said, the companies after me, they will bring you really good examples, the real use of AI on this field. But some words about how we think about the AI at FinTraffic. I would like to say we are not there yet, and we will never be, because as you all know, the AI is there. What it was 2 years ago, it's totally different what is now, and we can imagine it will be totally different in 2 years. So we have to keep going on with the AI. We have to learn every day from AI, and by these kind of ways we can improve our systems and services by using the AI. So how we think about the ways to use AI? We think about it especially gives us more precise monitoring of traffic and infrastructure. So new tools, which we already saw on last presentation, this kind of solutions are there and will be there. So there is a more precise monitoring of traffic. And it's also deeper and quicker analysis of data. It gives us flexible, future-proof methods for sharing data between stakeholders. And of course, AI-powered optimization is something we really think that will be there during the future moments. So the objective is enhance the situational awareness of various traffic and mobility layers in order to improve the way how we do that. As you can imagine, Mr. Freeman Bintek just mentioned about there is a lack of guidelines related to infrastructure, related to AI. It's really the same situation also in Finland, but we have something which is quite new. We have, in European level, we have a so-called European Artificial Intelligence Act, we call it AI Act, which gives some guidelines how to use it, and also some background related to the governance of model, and defining the detailed implementation of policy and including the specification of roles and responsibilities. So based on this work, of course, as a government organization, we have also provided our AI governance model, and we are working on this. Is quite new. It's not exactly finalized yet, but it's also a backbone how we as FinTraffic, we work with AI, starting from AI policy and roles and responsibilities, ending up to procurement and contracts, how we handle AI in the future. And as I said, we are not there yet. We will never be. So this is a living document for sure. So we have to work with this living document. And how we use AI at the moment, AI is utilized in specific areas of FinTraffic various operation. AI tools are available for our employees. We have lots of tests and pilots and proof of concepts at the moment, and also in some existing products already. Just to highlight few, automated incident detection. It has been there, especially related to tunnels already. But what we are working on at the moment is future system where it will be self-learning and optimize their own operations during the traffic management. One example where it could be used also. The other example is traffic situational digital twin, meaning that we are working as one example, intelligent transport operators desk, meaning that we are using the new technologies, AI and digital twin, in order to provide more tools for our traffic management, giving us an opportunity to make the better decision, make predictions, make faster decisions in order to manage the traffic. It means that we have lots of information from different areas, different solutions, different sources, and using this data, we can then provide more information and more predictions about the traffic risk measurements, road weather conditions, and traffic measures. So then we can have a really good situational awareness about the situation. Right now, what it will be in 15 minutes, what it will be in 30 minutes. This kind of opportunities gives this kind of new technologies. So just to summarize, main focus is road weather, traffic measures, and traffic risk measurements, and also would like to once again highlight using the third-party data and using the third-party solutions from the companies, because those companies are really aware of new technologies. Those can be used in order to provide new solutions. So from my presentation, the key takeaways, we believe the open knowledge sharing, like today here, public-private partnership, we are having an open ecosystem where we are all the time discussing with different stakeholders about this, and standards, because standards means replicability and flexibility. We are, of course, we are following European standards, but those standards are quite, how would I say, in line with international standards, so could be used also in Indonesia. And key learnings: proper data infrastructure is core. We have to have data in order to use the data, in order to improve our processes and services. And leveraging energy technologies, it gives us reusability, interoperability, open source also works and means flexibility. And practical cooperation in public-private partnership across borders in international level gives an opportunity to share information and learn from others, like we are doing today here. But anyway, I would like to say, keep it simple, but aware of opportunities, because there is lots of opportunities we have to take step by step. That's all what I have today, and would like to highlight that we are proud of having lots of good indexes at the moment. And the first one over there is the important one, being the happiest country 8 times in a row. But we are really willing to share our happiness with Indonesian people also to work together related to these things. Thank you very much.
Thank you very much, Pak Kimo, for your precise timing and a lot of key takeaways that can be a lesson for us in Indonesia. So let me summarize it in Indonesia, if I may. Jadi Bapak Ibu tadi sudah disampaikan di akhir gitu ya, terutama mereka juga akan membuka terus untuk kerjasama dengan swasta untuk pengelolaannya tadi. Tetapi di mana yang dipastikan itu adalah standar. Lalu tadi disampaikan mereka akan berusaha itu untuk standar internasional, dan juga tadi disampaikan sudah ada standar di EU ya. Di EU itu sudah ada tadi governance model EU AI Act. Itu tadi sudah disampaikan juga sama Pak Kimo. Jadi memang AI ini akan selalu berubah terus. Jadi misalkan kita ingin mengejar di finalnya akan susah. Jadi dokumen yang mereka buat tadi, governance modelnya, itu sifatnya akan diupdate terus. Jadi living document tadi yang mereka sampaikan. Lalu tadi key-nya juga agar bisa reusable, interoperable gitu ya, bisa dimanfaatkan yang lain. Tapi yang terakhir yang dibutuhkan adalah jangan lupa infrastruktur untuk datanya. Jadi untuk menyiapkan data AI-nya, infrastruktur datanya juga harus dipersiapkan. Dan tadi yang agak unik memang kita lihat dari Fintraffic ini mengelola untuk semua ya. Jadi kalau Indonesia ini mungkin kayak Kementerian Perhubungan tapi khusus traffic gitu. Jadi udah railways, udara, jalan, laut, semua mereka yang mengelola gitu. Oke, thank you very much Pak Kimo. So let me invite for our third speakers. Mungkin kalau boleh di-share CV-nya. Baik, terima kasih. So for our third speaker, we will have Pak Oli Tanerkowski. He will explain and sharing about digital monitoring for road network. And he is right now a Chief Partner Officer from Scan AI, and he is a co-founder of 3 innovative product companies. So Springfest OYG, a leading investment platform, and it has IPO on 2021. And the second one is Foros OYG, a pioneer in crowdfunding and financial services. And the last one is what he is working right now, Scan AI, a cutting-edge AI solution for business intelligence and automations. So the time and screen is yours, Pak Oli. You may have 20 minutes. Thank you very much, Pak Oli. Please.
Yes, thank you for the opportunity. and I'm super excited to present you the ScanY and all these challenges, the problems that you have been talking about. We all have the same problems, that we don't have enough resources, and how to fix this thing, that how we can use AI and automation to save resources, money, time, and of course CO2 emissions, and how to make the road maintenance also more sustainable. So like Kimmo is like a big, or FinTraffic is a big platform that collects all the data. So what we are doing, we are bringing the data for different stakeholders. One can be FinTraffic, but others can be engineering companies, consultancy companies, private-owned maintenance companies, or it can be cities or counties. Now I could share something. I have a phone at the moment and also a computer, so if I can share. When I have these two screens, is it possible to share? Is it sharing or not?
It's not yet, Pauli. Maybe you can reshare it again.
Yeah.
Yeah, it's here now.
Okay, excellent. So what we are doing, so for us is like having this road maintenance green infra revolution, and for the road maintenance, how to use digitalization, and for the automation for this one. So one of the problems that you have already told us, that it's like I think we have found at least 3 main problems or challenges that we have found solution. One thing is for that collecting the data is too expensive. So how to collect the data with, like, have a high value data, but it needs to be budget friendly. So that's one thing that we have found out, how to collect the data with let's say good price. Second thing is that when you collect the data, is when you analyze the data, I would say that less is more. If you have too much data and you are running it through the automation or any kind of AI, let's say, models, it also comes too expensive. So that's also the second problem, the challenge that we have been taking care of. And the third thing is like for the industry, like for the maintenance industry, how the industry or the different stakeholders, how they can adapt the new technology. Because if you need to, it takes time to educate your workers and other stakeholders. If it takes too much long time, it's really hard to adapt the technology. Or if the investment to new technology is too much. So that's also third thing that we have been solving this kind of challenge and problem. So one thing between why to use AI-powered maintenance and automation, it's that the speed is much faster. You can get so much more data, where you can start making different kind of patterns and models. And AI doesn't sleep, it doesn't need coffee, so you can run it all the time, and the data quality gets better all the time. But first, of course, you need the training, and the problems be like in different kind of environments. There is the problem that how to get this kind of a high quality data. There are different ways of monitoring the roads, how to gather the roads or getting the data. It can be, you can have sensors, you can have LiDAR, laser technologies, different kind of models for this one. So you can get this information from the community. People can say that, hey, here's problem in the road. There are so many different kind of ways to do it. So for us, is to bring like a simplified data for the decision makers with reasonable price. And the lasers and lidars, they have their own good points. I think the other company, road scanner, they will provide really exact information from the road. We are not there because we are using computer vision, mobile phones to collect the data. So it won't be that precise compared to laser and lidar. But why to use us? Because when we are using computer vision, we can have a fleet of places where you can collect the data. Mobile phone costs like, even expensive, costs like 1,500 euros. But for lasers and lidars, or they having this kind of special cars, they are really expensive. But if you need really, really accurate data, then the lasers and lidars are, there is like really good, extremely good. So for the benefits, you can have like, let's say the data can be neutral, it can be same kind of quality. One of the biggest, let's say the benefits are that it's really easy and quick to implement, to adapt, to start using it. Like for us, it would be honor for us to do a pilot in Indonesia, because the pilot can be really, really fast and easy to check out and show that, okay, does this really works? How much it needs to implementation in the local environment, which are the new needs for the, maybe for the software, but really fast to implement, and then to scale up like in the whole of the islands. You don't need that big kind of investment to do it. And for, of course, the main things are, of course, the safety of the people on the roads. So this, our solution brings that one. And of course, what is important, that the citizens are more satisfied with this kind of solution. So our customers are like a national government, Finland government at the moment, and then are the local also stakeholders. But now maybe our biggest customer are the private owned companies, which are engineering companies and consultancy companies, because then they can collect the data and supervise contractors and other maintenance companies, so they can supervise them. And this, our also solution will be most likely in next year that we could use them also in railways and airports in different kind of, let's say, challenges what they have there. And for ESG, if there is a sustainability goals, ESG goals, we can also provide them, because then you can really save a lot of resources by optimizing the road maintenance and construction of the roads. So huge benefits of using the new technology. And one thing is, so this is like how it really works. So you put on the mobile phone on the windshield, you start recording the roads. They are like, you can have using manual, so you can use your voice that you see something special on the road, and it will make a report that what it happens, and it has timestamp and GDS coordinates. Or you can start using automation AI for the picking up the potholes. And if there are any kind of that it needs to be people or the cars needs to be kind of unidentified, we can also do this one. So one thing that was in the presentation is that this is the big problem, that how do you, for the models, how do you teach them? How do you pick up the potholes, not the shadows, not these different kind of colors on the roads? Because that's a really, it is really big problem. And that's something that needs to be solved in every country, because there are different kind of let's say, problems for that one. So we can use really kind of high quality video, computer vision, or low quality. So this is kind of picking up the road signs on the road. You can make automatic reports about the road signs, and you can have this kind of, let's say, infra balance if needed. There is in Lapland, ELY, there's one Finnish maintenance company, Pimara, which is, I think, third biggest company in Finland. So government can supervise what they do. So have they done their work or not? And other thing is how to optimize the maintenance. But this gives you the government or the other municipalities or stakeholders audit trail where you can check out what has been happening, or you can come back for the video that, or make these kind of observations that does it need, what needs to be done. Also for in Finland, that for insurance companies, they can check out that what is happening. Second thing is that we made for city of E that there's a heat map. So the road condition is that there's like a red, yellow, green, and the red ones are something that they need to be fixed. Otherwise, it's like a dentist. Can you hear me?
Yes, please, Pauli. Sorry, I just mute.
Yeah. Yes. So for the heat map, it's like for the potholes, as you know, that it's like a dentist. If you have small hole, fast to fix, cheap. But if you don't have time and money to fix out the potholes and cracks, they will grow, and the price of the repairing the road or the teeth will be much, much more expensive. So we made a heat map for E that the red ones are that they know that if we don't fix them, the repairing of the road will be, at least here in Finland, 10 times more expensive, and there might be start coming accidents. So then it's more like the decision making is more like the humans still make the decisions, but this is more like a data-driven decision making, not about who yells the loudest that I need my road fixed, but this is kind of, you can show your public and citizens that, hey, we know that this road needs to be fixed now, because we also that we need to save our resources. So, and where put our resources, so this can bring help to the municipalities or who decide that where the money really goes. And of course, this brings transparency for the whole decision making, that okay, let's fix these ones, and if we have money, let's fix also the yellow ones, because then we can save money to use this kind of preemptive road maintenance. And there are different kind of maps that you can use and check out that what's happening on the roads, but this is something that can be decided with different kind of stakeholders, what you can see, what you can do, and check out that what's really happening on the roads. And the difference is, like when you are using this AI computer vision mobile phone solution, you can collect lots of data and many times. Because if the data collection is too expensive, collecting the data like monthly, weekly, that might be just incredibly expensive and that cannot be done. But with our solution, you can do it like even like once a day if needed, depending on what is needed. But this always needs teaching for this one. So this was my presentation. If you have any questions, I'm happy to answer the questions.
Oh, thank you, Pauli. We still have 8 minutes. Do you want to elaborate more, maybe? Or enough for now?
If you have any questions, I'm happy to.
Oh, okay. Okay. For the Q&A sessions, maybe we will do this after the last speakers. Excuse us, Pauli.
Okay. Yes, okay. But if I'm okay with this, or
Yes, please. If you want to continue.
yes, okay, then let's say I was in Kosovo, in Albania, with Fin Traffic and Fin Partnership, and for them, because also for them it's like really important to how to find this as low cost and still get high value data for them. It's also really important. And the second thing was for this road maintenance, for supervising what the maintenance companies are really doing. So it brings like those things are really important. But I think the third thing is that for the preemptive maintenance, that will be where I think at least many countries, also in Finland, that we can save huge amount of capital, the money, plus having the sustainability goals. It's really important. And this kind of system, we can implement it, of course, like having these APIs with other systems. And we are more than happy to have partnerships in Indonesia, cooperation, and we can have the pilot like in really fast space if needed, because these new days, let's say these technologies and stuff, they can be developed really fast nowadays, so that you don't need, let's say, 10 developers, you need 1 or 2 developers, but they need to be really extremely good. So, but for opportunity for us is that, as I saw you, that the problems that you have, that I think we have a really good solution for you. And we are also interested in cooperation with universities and of course with the governmental side. We have cooperation here in Finland with the University Aalto, the technical university, and also in other partners in these big engineering companies. They are also now testing our solution in middle of Finland, in Lapland, and because there are dirt roads, so roads without asphalt. But the roads are really important for us because of the industry sector, for the forest industry, mining industry, and other these kind of metallurgy industries. So the engineering company is now testing our solution at nighttime, plus in the dirt roads. So I think that will be our next step innovation that will come, let's say, if not this year, next year, it can be done. So we can do the both roads, asphalt plus the roads without asphalt. And the speed of how you can do it's now what we have been developing. It's really fast. At first it was something like 50 kilometers per hour, and now it can be almost be like 100 kilometers per hour. So doing this inspection can be much faster than it used to be. But yeah, from my side and our company side, thank you for the possibility to showcase our solution for you. Thank you.
Thank you. Thank you very much, Pak Oli. We appreciate your times. What interesting solutions from Scan Y. And let me explain summarize in Indonesia. Tadi sudah disampaikan Pak Oli dari Scan Y ya. Tadi ada beberapa tantangan yang relatif sama sepertinya. Dari pencahayaan, udara, ada bayangan gitu. Cuman sudah terlihat benefitnya itu kalau menggunakan AI, dia lebih cepat, bisa banyak pattern yang bisa dideteksi, sama AI tidak tidur tadi katanya, jadi bisa 24 jam. Lalu bila dibandingkan dengan digital twin, misalkan laser atau pakai LiDAR gitu, itu mungkin memang akurat, memang bagus banget gitu. Cuman ada kelebihannya kalau menggunakan AI tadi, salah satunya bisa langsung diadoptnya cepat, bisa langsung diimplementasi gitu. Bahkan tadi ditawarkan kalau pilot di Indonesia bisa di setup dengan waktu cepat. Lalu tadi disampaikan contohnya udah dipakai selain dari pemerintahan, dari perusahaan kontraktor gitu ya, konsultan sama kontraktor untuk supervisi pelayanan jalannya sepertinya. Lalu tadi ada fitur mobile yang menarik, ada menggunakan perintah ada recording suara ya untuk timestamp, lalu juga bisa langsung disensor mobilnya tuh buat privacy, sama bisa ada report buat sign-nya ya. Lalu juga ada heat map, bisa pakai API, dan tadi yang terakhir inovasi bareng universitas dan perusahaan tambang ya. Jadi untuk yang jalan-jalan unpaved dan di malam hari juga dicoba pakai solusi scan wide. Thank you very much, Pauli. Let me invite the last speaker before we are moving to the Q&A sessions. So for the last but not least, we have Pak Timo Sarenpa. As a development and coordinator from Road Scanners Limited, he will explain about automated road surveys and digital twins. So his education background on 2014 as a Master of Engineering in Management of Technological Competence from Lapland University of Applied Sciences, and before he has a Bachelor of Science in Software Engineering from Rovaniemi University of Applied Sciences. And he has a work experience from 2024 until present as a development coordinator for quality specialist road scanners worldwide and Finland, and before as also the same development coordinator road scanners, and the third one as a quality manager in Rovaniemi also in Finland. So Pak Timo, the time and screen is yours. Please, Pak.
Okay, thank you. Let's see. Okay, can you hear me and can you see my screen?
Yes, we can hear and see your screen fine.
Great. Thank you about this opportunity to speak about automated road surveys and digital twins from the road scanners point of view. I'm speaking in Rovaniemi, northern Finland, close to Arctic Circle, and just got the first snow this year, this morning. As a company, Road Scanners, we have 3 business sectors. Half of the company is doing a consulting work in the field of existing infrastructure. So Road Scanners' specialty is that we have been focusing more than 20 years on managing existing infrastructure, roads, airports, rails, and so on. And half of the company is then divided to software and hardware development. We have our own hardware products. I will present 2 of them in this presentation, and to relate it to this hardware, we have our own software for processing the data. As mentioned, Road Scanners is 20 years old company, and we have been working. We are proud to say that we have been in all continents, so quite worldwide operations during these times. And to have this kind of wide experience, company needs to have one like a specialty. And in Road Scanners, our special expertise is ground penetrating radar, and how it links to road asset management and AI and things like that, is that using this technology, we can see beneath beyond the surface. So what is under the pavement? What is causing those damages? It's interesting to see what is down there and what kind of reasons there might be for surface cracks and damages and performance in general. And shortly, system is so that transmitter sends the pulse to the ground and receiver listens that, and we get this kind of, I would say, grayscale data, and then we have engineers interpreting different layers from this data. But this data tells much more than layers, and to analyze this cost-efficient AI is needed and used quite a lot. In addition to that special technology, where I would say we are in top 3 companies in the world using GPR in road asset management, I would highlight this second topic, proactive maintenance. We have had 10 years project in Finland. Our roads are built quite long time ago. We are not building new roads that many, only motorways and few kilometers per year. But what is our real problem is that our old road network is getting worse and worse, and surprisingly we are running out of money to maintain that. And quite simple solution is to ask more money from government, but there is certain limits on that, so something needs to be done different way. I see you are taking steps towards AI and asset management systems, and for sure those will help, and we have done the same here in Finland. Another expertise, these low traffic roads. It's quite important, like Kimmo said in the beginning, that we are quite wide country, and we have a huge low traffic road network where the amount of traffic is not high, but they are important for industry economy, how to get goods to the market and so on, and how to maintain these roads. Go with the low cost is I think a global challenge in future. And what I would like to highlight at this step is this quality assurance, that it's in the asset management. When we use digitalization in asset management, easiest is to stop making how to say second quality or low quality, that what we do, what we repair, it's important that it's repaired well, and also the construction and design market is working well. Then to the products itself, what we are using in our daily works, and how we implement those proactive maintenance things are that we have this kind of road doctor survey van, like Olli said, comparison to these dentists. Our product Road Doctor, it's been our brand for years from the beginning, and the healthcare of the roads and assets is like a business idea of the road scanners. And proactive means that you just need to take care that your kids are brushing their teeth. So that is cheap cost economic way to keep teeth in good condition, and same applies to the infrastructure, that you need to focus on daily maintenance, keep your roads in good shape, and try to avoid damages. So nice goal is that you should fix roads before they get damaged. But back to this road doctor survey, when it's all in one tool for collecting the data. As the sensors, we have video cameras, we have laser scanners, we have accelerometers, and then we have this ground penetrating radar here in front. There are several different kind of GPRs. You can have a 3D GPR which produces a bit more data, but it gives you data from the width of the vehicle. These radars, what's in the picture, they provide thin, how to say, let's say 20 centimeter wide sample of the structures. This small one can see deeper, it's lower frequency, and this orange one is high frequency antenna, which can be used for evaluating the pavement thickness, pavement condition, and the cracks which are not yet visible, so delamination, stripping, things like that. But the idea is that this is a tool for creating some kind of digital twin. There are many kind of definitions of the digital twin. But we understand it so that you have surface and subsurface information available, plus road condition and some trends, how this modeled infrastructure is developing over the time. And yeah, all in one solution, so it's easy to operate, and you get subsurface and surface and images in one run, and you can send this vehicle to the road network, and then when it comes back, or you can transfer data online, you get quite nice data for doing rehabilitation planning or evaluating what is the situation on the road for your design engineers. This is an engineer view for the data. This is from our software called Road Doctor, and quite much data in the view, but let me explain what is there. So left is image, that's clear. Top, we have from LiDAR, we have a rutting on the wheel paths from this opposite lane. So we can see that there is a rutting on one wheel path on this opposite lane. Then we have this driving lane, what this vehicle is driving here. So rutting on the wheel paths is demonstrated this way. Traditional road measurement devices, they present this rutting as a line graph. Here is 10 millimeters, here is 15 millimeters of rutting, but when we visualize it this, could I say, digital way, we can see that if the rutting is wide, then it's caused by heavy vehicles, which is, by the way, the real problem in Finland. We have 76-ton weight limits, and we have very thin pavements, plus we have a winter time and spring toe weakening time. So that's one knowledge what we have to share if you have some issues with the heavy vehicles and their effects to the road network. But here is the road surface quite precisely modeled. And then this brown-gray diagram tells about road structures, that it's now pavement thickness is in the brown, and we can see how it is changing, and base course is gray. And now we can compare data that why this rutting is bad here. Is it caused because of the structures or some other things? But this is which we called a bit like an intelligent asset management, that we try to find out reasons for the damages, not only patching to this surface and probably after 3 years again, and then after 2 years again, and then after 2 years again. So that is like a repeating work and reactive and not intelligent. In addition, there is falling weight deflectometer data. So we can have here traffic speed deflection data. Nowadays, new systems can record with the traffic speed bearing capacity, how stiff the road is. So combining this stiffness of the road to the layer thicknesses, we can get some information about material quality. We used to say that designing and repairing existing road is way more difficult than building a new road, because when building a new road, you have known materials, and you can, and in the design there is a constant layer thicknesses. But when you enter to the designing of existing roads, you are in the trouble because you don't know what's there, what kind of materials they used there. 30 years ago, no documents. So that's why this kind of road surveys are needed. Left bottom corner, there is visualized this rutting data to the point cloud data collected using this vehicle. So all this data except bearing capacity information is recorded by one vehicle. And I would say that without engineering experience in the data collection, but in the data processing, engineering is needed. More about this road digital model, I was focusing a bit this digital twin, how we understand digital twin. Twin is that we have this surface model, so we can see road width, crossfalls, ruttings, is there buildings, how the road environment looks. A lot of damages are related to the private road cross sections, or there is a road cut or the road is changing from soft soil to the hard soil or things like that. But subsurface model is important also. Normal presentation is layer thicknesses, but for this presentation, I took data. You can see it there under the road. There is a moisture, relative moisture, measured using this GPR technology, which is one of our key expertise. And the road digital model includes also the condition data. So from the images, you get damages like Olli presented in his presentation. They are like a functional condition, how the road owners, road users feels the road. And then, for example, this moisture could be one parameter in addition to those thicknesses and bearing capacity. and this data is more like a structural data. And based on this, our pilot project here in Finland, 10 years pilot project, these trends are quite important. That this 10 years project was so long that we can analyze that if we pave before we get the damage, we get the great savings compared to the maintenance operation when the surface is damaged already. That it is a bit difficult to explain for public that why we maintain good looking roads, but we have that intelligence that we know that that road will fail within the next 2 years. So now it is the optimal time to make a corrective operation, so you get much smaller lifetime costs. Another example what we have been working in Finland is that those excavators, the machine control systems are getting more popular. And in here in Finland, if you build your own house or you have some house building project, it's clear that your excavator operator will use a machine control system. But when the same company or operator comes to dig our roads and cleaning the ditches, there is no model used for this, cleaning the road ditches. And this daily maintenance operation, that cleaning the ditch, is quite simple, low-cost work, but it affects to the lifetime costs a lot. That keeping the water out from the road structures is again important thing to avoid cracks and damages. And we have found out that those roads, they have been built well. So if there is a drainage problem, most probably it is because the location is wrong, that how you get rid of water on the flat surface, how you get it out. But also the history of the road is the one that first the road was small, then it's widened probably 2 or 3 times, it's paved, but the landowners, the limit of the road area is not updated, and it's a bit difficult to update, at least here in Finland, that you cannot build road to the private land. So making this kind of digital model, is this a digital twin? It helps on cooperation between different stakeholders, because we can bring borders of the road and private area, and then we can tell for the landowner that we are expanding this road, making ditches more deep, and we are cutting from your field, but based on data, we are not still yet on your field. Even it feels that we are cutting private property because farmer is farming on this public area. But bringing these tools, this kind of tools, how you show and present those digital twins, or you measure this system, there is not a lot of money available. For example, cleaning the ditch is very low cost work, so the modeling and tools cannot be expensive. And depending of the market, that is it public or private work, but if it's private companies, they need to get money. They they won't buy a augmented reality system just for having nice picture. They need to get their money back for their investment. So they cannot be too expensive.
Excuse me, Pak Timo. I think you have finished 20 minutes, but if you want to continue, maybe for another 5 minutes.
Okay, I will try to go in 2 minutes or
Okay.
3.
Thank you, Pak.
That was my main topic. Then I enter a bit to the same field and Scanway was already presenting, so I'm not presenting too much about that. But another point of view is this automated road condition measurements and using AI on that. We have this kind of system where we have an accelerometer under the seat, we have a laser scanner behind, and then we have a camera inside and mobile app to manage the system, and it collects rutting, crossfall, roughness, words, and images, edge drop every second. So collecting the data and sending it to the cloud. So this is kind of big, small brother of this road doctor survey vehicle, which I was presenting in the very beginning. I will jump over this slide. It is just meaning that crowding is more cheap than those high-end road survey vehicles, which requires engineering intelligence. But from this accelerometer data, we can detect that what kind of unevenness there is. So this is sample from the gravel roads. So this kind of vibration is a very common problem when we have a nice summer, dry, sun is shining. So we can see data high values here in the 40 to 80 hertz. So vehicle is going quickly up and down. And opposite is our frost-related problems, these kind of large wave bumps where the vehicle is going probably 1 or 2 times per second up and down. And yeah, time flies, so I will jump over also these slides. Probably you can read it when you get this presentation, but I summarized to this slide that this kind of road condition monitoring, what I was presenting in the end, automated, enables this kind of comparison of different maintenance area. If you have privatized daily maintenance, that especially in dirt road management, how is the timing of the operations and what is the quality of the operation? Do you grade deep enough and things like that? When you have a data, you can compare different operators, different contractors, and also different timings. That here we went 1 week later, here we went 1 week earlier, and then result is that here the roads are in better condition. Sorry about going over, but thank you.
No, yeah, thank you, Pak Timo. So, what a very interesting explanation of road doctor. He said it's a healthcare of roads. So, thank you, Pak Timo. Let me just a little bit summarize for the audiences Indonesians. Jadi tadi dari Pak Timo dijelaskan ya, salah satu tujuan digitalisasi, digital twin ini sebenarnya paling penting itu karena uang terbatas dan aging infrastructure di Finland tadi untuk mencegah penanganan kedua, ketiga gitu. Jadi penanganan berulang. Inginnya itu sekali ada penanganan langsung bagus. Maka tadi dicontohin digunakan dari road scanner tadi bentuknya fan, di dalamnya itu ada 2 GPR, jadi GPR langsung nempel ya. Ada yang buat high frequency, low frequency, tambahin lidar juga, ada kamera thermal, kamera sama akselero, DMS sama GPS gitu ya. Langsung kelihatan tadi dimasukin ke software digital twin-nya, ada cross section-nya, ada gambarnya. Di surface yang di permukaan ada bisa dapat rating. Terus juga yang subsurface ada layer thickness sama moisture juga kelihatan. Kalau di combine, tujuannya tadi bisa untuk mencari reason of damage gitu. Jadi penanganan kerusakan itu sebenarnya karena apa? Dilihat dari rating sama tadi ya layer thickness dari GPR supaya penanganannya nggak berulang gitu. Terus tadi lebih mudah karena sekali jalan langsung semua datanya terkolek. Lalu tadi yang penting terakhir ada beberapa varian juga, tadi ada yang smaller, terus juga ada bisa crowding ya, kayaknya menggunakan public, keluarin accelerometer doang, terus nanti bisa disandingkan time seriesnya. Nah mungkin gitu kira-kira. Thank you very much Pak Timo. So the presentation from Pak Timo finish all of our 4 speakers. So we are entering the Q&A sessions. Jadi Bapak Ibu silakan, ini mungkin kita alokasikan 35 menit untuk tanya jawab. Mungkin akan saya prioritaskan yang bertanya langsung. Jadi mungkin waktu dan tempat Bapak Ibu silakan. Mungkin saya coba bisa di unmute ya Bapak Ibu. Silakan tolong sebutkan nama dan instansinya Bapak Ibu. Baik Pak Cahyo ya. Silakan Pak Cahyo.
Baik Pak, terima kasih. I prefer to ask question in English if I may. I'm very intrigued in the first presentation about data sharing and process sharing. I still don't understand about data sharing. Is data sharing standardized data? Is data for the output or data collected, or it's mean data in the metadata? We could understand that data output for road condition is very limited, and we know its variable is only for like IRI or SDI, and there's no more. There's nothing more that we could analyze. What kind of standardized data did it mean? Is there the output or only data collected, or do you mean a metadata? So its application could talk each other seamlessly and exchanging its data without any converter or any adapter. The second is the process, standardized process. We could understand that every application have a very specific algorithm that was to avoid copyright infringement. We could understand too that every process, every application will not its own source code freely, and even they would not undisclose their own algorithm to us. So in this standardized process, we need to elaborate what kind of standardized process that first presenter mean. I want to ask too about definition of the AI application here. Do we need AI to give some kind of future prediction of current condition with any given time and any given variable? If we could recollect about IRMS in 8 module, IRMS could predict existing condition for, let's say, 8 years with given road fund. They could say with with fund about how much million, the condition will be improved or the condition will be worsened. Or it's kind of PKRMS is enough to be said as an AI tool, because it's so many data involved in that, and it can give indication. Of course, we have to interpret it further, but in this condition, I have to ask about abilities of its application to give a cognitive ability as a human have, such as decision making, uh, problem solving, and even given an advice. And lastly, I am very impressed about the road doctor. It have very much state-of-the-art tools like GPR, cone penetrating radar. It gives so many variables that we could not have right now. To see under the asphalt is very great improvement if in our calculation about road condition, such as density, water content, and layer thickness. What I want to say about the road doctor is, could a road doctor give a prediction if there is an improvement, or could give an advice the minimal improvement it needs to retain its current condition for any given time? Yes, thank you for your time, and good evening, ladies and gentlemen.
Thank you, makasih banyak Pak Cahyo. Jadi ada 3 pertanyaan tadi ya. Izin Pak, 2 ke Pak Firman terkait standardized data sama future prediction. And for the third question is directing to Pak Timo regarding road doctor, how it can make, does it can make prediction and improvement prediction ya, Pak. Mungkin Pak Firman duluan, mangga Bapak.
Okay, I will respond in English too, Pak.
Yoi.
So first, about standardized data. So standardized is about all stages for preparation of data, from the preparation, from data acquisition, and to storage. So we talk about calibration. We talk about the process, how to get the data and how to keep and storage the data. For example, the format of data, the metadata also we standardize. So it should be that all stages for that process should be standardized. Then we don't have right now. For example, national standard for data, raw data, as example of IRI, roughness data, may be different from provincial data, maybe different from local government. For example, the road ID. The road ID is the simple thing to do. It's very different. We don't have standardized road ID. It's very different from provincial provincial and local or kabupaten road ID and national road ID. It's very simple things, but we don't have standardized it. So it's very difficult for us to interoperability about the data, exchange data between central government and local government. It's very hard because we don't have any standard. If I say fair is like this for national standard, it's very different. If we talk about fair or good road in local road, it's very different. We don't have any standard for it. We don't have same perspective about good, bad, poor, and medium road condition. It's very different. That's we need to standardize everything. And the second one about the prediction for future. So we call about predictive maintenance. So proactive, we are still in proactive. So there are 3 kind of asset management. First is reactive. Reactive is when there are some damage, we fix it. The second one is proactive. Proactive, which means we have models, we call detection model, and we predict the damage. and we have model, so we can predict, but it's just model. It can be false. The model is we use for all network. We calling proactive asset management. But the state of the art is the last that we hope we can reach that. That's predictive maintenance. What the difference is proactive and predictive? Predictive, which mean we have own models for every segment. In proactive, we only one model for all countries. In the predictive maintenance, we have model for every segment. So it will be more accurate, and I think AI will be a huge play to help us on the predictive maintenance in the future. So PKRMS current situation is still on proactive. Is proactive. We have models, but the models is one for all. For example, the models will work in Jawa Tengah, but the same model we apply in Papua. It is fair? It's not. It's different. The situation is different. The quality of the pavement is different. The deterioration will be different. But in the proactive, we do have same model for all. But in predictive, in the future, maybe if we have a lot of data, there will be a model for every segment. It's very unique for every segment, but it will be more accurate and will be fair. I think that's my response.
Thank you Pak Firman. Mungkin Pak Cahyo izin langsung yang pertanyaan 3 dulu kali ya Pak ya. Nanti kalau ada tanggapan silakan Pak Cahyo. So for the third question, I invite Pak Timo if you can respond.
Yes. So just let me know if I didn't got it correct way, but this in our case in Finland, I'm sorry I cannot come to your country and say that your roads will fail this way. So you have a knowledge there. I would say that more is this capacity building or knowledge spreading that you have there engineers who knows the problems on your roads, and that knowledge needs to be combined with collected data. Example from Finland, this our 10 years project, how to improve, I would say, predictive maintenance practices, was that we calculated annual payment cost for each meter. And then we start to find out that where is the most expensive meters, and those are paved quite often. But in Finland, this rutting is quite like the main reason for doing the rehabilitation, rutting and damages. I don't know, rutting is probably not that big problem in your country. It's more cracking, I guess. But this way we found out the, let's say, weak links of our road network, and then our engineers starts to focus that what we should do to get rid of these most expensive meters, because we spread our maintenance budget with our network length. And if we try to find some positive, I would say that most of the roads are performing well. That even we say that road from here to there is in bad condition. If we take a precise look, based on our research, it's enough that if 30% is in bad shape, road users says that that section is bad. But yeah, we need to bring data to your road engineers, and they focus on those short problem sections. A bit like a meter by meter. Your contractors or market is not fan of that that approach because they need to move the equipment and start and stop the site often, that they would like to do 10 kilometers in a row. But when we get these weak links fixed, then we can go homogeneous sections and longer maintenance operations. So yeah, could it give a prediction this way or that way? Vehicle and AI, I'm sorry they don't give you an answer, but we can help you on making this decision.
Oke, thank you Pak Timo. I think it's answer all of the question. Pak Cahyo mungkin ada yang mau
Yes.
ditanggapi?
Thank you very much, Mr. Firman. From the explanation there, there's so much room we could improve about our application in the road, because there's still we cannot predict about the future, and I think we still need an application as a third party that give us a subjective view on this matter. And for Mr. Timo, I just hope that your tools is not just a road doctor, is not just a bin counter, but also a bin processor. It could make many things that we hope. But that's many variable that it could get that we don't have right now. Thank you.
Thank you very much Pak Cahyo. Mungkin
Excuse me, can I shortly
please.
add a
Please,
note related to the standardization and using a standards? Because one option is also, if I think about the Indonesian market and Indonesian improvements related to the using of data, as we Finns, we comes from European area, so we are following the European standards, and as a matter of fact, we do have quite well situation related to which kind of standards we are using related to roads at the moment. So one option is also in order to help a little bit from our side in order to look at which kind of standards we are using in Europe, because it also gives an opportunity to use European solutions, because our companies, our solution providers, they are quite used to use these standards in Europe. So most likely, if you like to have something which is already existing and not so costly because it's already existing and it's replicable to other countries, maybe to look at if you can use also European standards for that. That's just a comment related to this standard discussion.
Thank you Pak Kim for your addition. So to give more opportunities, thank you Pak Cahyo once again. Maybe let me invite the other, if there's any other questions from the participants, from the audience. Silakan Bapak Ibu kalau ada pertanyaan, bisa langsung raise hand atau di unmute. Tadi sudah saya nyalakan ya, bisa di unmute, silakan. Silakan kalau ada yang ditanyakan, tadi ada yang di chat juga. Atau mungkin ini saya invite, sambil menunggu, saya invite Pak Firman mungkin. Pak Firman ada yang mau ditanyakan mungkin?
Yeah, maybe I want to ask Timo about GPR, ground penetrating radar. It's interesting because it's kind of data is hard to interpret, but you do that in network level. It's usually in a more specific area, but you put that signal survey for network signal because the interpreting the data is very difficult to analyze. How you can handle that issue, so you can you do the survey in very network level things, because it's very time consuming to analyze and a high human intensive expert on that. interpreting the analysis, the GPR thing, how you can handle your team that issue? Any AI in the future for interpreting that kind of data?
Good question. That's the most difficult part to get that, and difficult to say beforehand that is it how long it takes to interpret data, because you don't know what kind of structures there are. That if you have 40 years old structures and it's built many times, even if you dig the layers off, you cannot separate them, so that is difficult. But yeah, as I said, that we have done that 20 years. We have many engineers with a long expertise, and that expertise does not mean only GPR, signal processing expertise, but you need to have a knowledge about how roads are built, that what you try to interpret, but AI is our tool for that we have been developing 3 years. We have thousands of the kilometers data collected, a lot here in Finland, but as I showed the map, we have collecting all around the world a lot of data. So we have been teaching AI to help on that difficult task. And yeah, radars are getting better, unfortunately, or fortunately. This 3D radar is producing more and more data to interpret, so work is bigger and bigger, but you don't need to always interpret everything. And as a beginning, it's also good that when you do the data collection, you collect the data, and you don't need to interpret everything. You have sources that here we have problems, here we have newly built road, we can check if the construction thicknesses have been correct and so on. So I'm trying to say that you can interpret only some part of collected data. But the important is that when there is a need, you have the data to interpret. Yeah, long answer, but that AI and optimization is the answer.
Okay, thank you. And maybe one last question to Kimo. I am interesting about PPP, public-private partnerships for data collecting. What kind of type of PPP do you do in your organization? It is like long-term contracts to the vendors, a long-term contract to the company to collecting the data or to manage the data, or what kind of PPP have done in your organization?
Thank you for the question. Just to start with, because we are really much data-driven organization and we are working together with multiple organizations, I already put a link related to our traffic data ecosystem over there on chat. And if you look at the traffic data ecosystem, it's an ecosystem where we have more than 200 members working together related to data-driven things, because there is lots of regulation, there is lots of standards, there is lots of stakeholders working together in order to harmonize how we use the data, how we work with the data, how we get more value out of the data. So we have something like, if I remember right, we have 6 different working groups at the moment around FinTraffic, working for this kind of harmonization of using data. Of course, like I said, there is a lot of regulation coming from European side at the moment. So we have to be aware of that. Not only FinTraffic knows what to do, but also the other stakeholders, the companies, cities, and ministries and agencies. So we are working together in order to harmonize how we use this kind of data framework. And this is exactly quite typical how Finns are doing these things. We are discussing about these things before this kind of procurement processes are starting, because during this kind of open discussion about how we should do this and how we should manage all the stakeholders' needs related to data and sort of, then we can take care of that this kind of needs and challenges challenged by the organizations are already inside the discussions. So this is exactly one of the ways we are doing this PPP, public-private partnership. So it's open discussion before we enter to procurement processes, because during the procurement processes, of course, we have option to have hearings for the stakeholders and the companies, but normally those are quite strict processes when you are procuring something. So that's why we think that this kind of open ecosystem where we can have all the participants which are interested about the data and using the data, those are connected together and collected together, working together, and open discussion about these things. And afterwards, when we go to the procurement processes, those companies and stakeholders can be sure that those needs and thoughts they have are already in on that process. That's one of the examples, which is crucial for us.
Thank you, Pak Kimom. Pak Firman, cukup mungkin?
Yes, thank you.
Thank you.
Maybe
Thank you,
we
Pak.
can discuss later.
Yeah, for sure.
Kind of.
Thank you, Pak Firman, Pak Kimom. So I invite again for the audiences dari Bapak Ibu. Silakan kalau ada yang mau ditanyakan. Sepertinya waktu masih ada sekitar 5 atau 10 menit ini. Bisa 1-2 penanya lagi. Silakan. Belum, mungkin saya yang tanya mungkin. So if there's still no question from the audience, maybe I will ask to Pak Oli. Pak Oli, you said before that it's kind of why you said before less is more. You said that too much data could be ineffective. So that's why this is why you share the ScanY technology. Can you elaborate about that statement, please, Pak Oli?
Yes. So these kind of questions that about the screen resolution and like this tree shadow, and about the data collection, that what kind of data there is, because it's like when we are collecting the data, we use 5G or 4G or 3G to send the data to the cloud so that the data is available as fast as possible. So if you're using really high resolution videos, so sending the data out to the cloud, it gets more and more expensive or harder to send. So if you're collecting a huge amount of data, you cannot have this kind of a fast monitoring way of doing. Then, of course, like storing the data, it also brings you costs. So if you have too much data, it will cost so much that then the municipalities or the stakeholders will say, no, thank you for the data.
Thank you, Pak Oli, for the elaborations. I think that's clear it out. Bapak Ibu, silakan. Ada yang mau ditanyakan lagi? Mungkin bisa langsung unmute atau raise hand, silakan. Tinggal 1 menit lagi nih sebelum jam 15.45. Bu Iklima sudah memunculkan wajahnya ini, sepertinya sudah mau maghrib. Belum? Ya, Bapak Ibu lagi nunggu 15.45 ya? Oke, kalau belum mungkin penutup saja dari saya ini. Thank you very much for all the 4 speakers and all the audiences that accommodate their times to present in this webinar. And this is a really insightful session for us. So I hope, especially from Bintek Jatan myself, we can discuss it further, especially with Pak Kimo, Pak Oli, Pak Timo, and especially to Bu Prisi to accommodate all of this event. So I will give back the screen to the panitia, to MC Bu Iklima. Once again, thank you very much for all of us and for all of the speakers. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh. Terima kasih, Pak Vito. Terima kasih kepada Bapak Vito Berkat Harahap yang telah memandu sesi paparan dan diskusi webinar kita hari ini. Kami juga mengucapkan terima kasih kepada para narasumber kita, Bapak Firman Permana Wandani, Bapak Kimo Lis Hyurunen, Bapak Olita Nerwoski, dan Bapak Timo Sarenpa atas perkenan waktu dan materinya serta penjelasan yang telah dibagikan kepada kami. We would like to extend our sincere appreciation to Mr. Vito Berkat Harahap for skillfully moderating today's presentation and discussion session. We would also like to express our heartfelt gratitude to our distinguished speakers, Mr. Firman Permanawandani, Mr. Kimo Lee Sirunen, Mr. Oli Tanerkoski, and Mr. Timo Sarenpa for generously sharing their time, valuable insights, and expertise with us today. Bapak dan Ibu, kami informasikan kepada seluruh peserta webinar untuk dapat menjawab soal-soal post-test yang linknya akan kami bagikan. Sebagai syarat penerbitan sertifikat, peserta diwajibkan untuk menyelesaikan post-test karena selain registrasi, peserta diwajibkan untuk menyelesaikan pretest dan post-test. Ladies and gentlemen, we would like to inform all webinar participants to kindly complete the post-test through the link that will be shared shortly. As a requirement for the issuance of the certificate, participants are expected to complete the post-test in addition to the registration. Please note that both the pretest and post-test must be completed accordingly. Baik, Bapak Ibu, akhirnya berakhir sudah rangkaian acara kita pada hari ini. Kami selaku panitia mohon maaf apabila terdapat kekurangan selama berlangsungnya webinar kita hari ini. Semoga kegiatan ini dapat menambah wawasan dan kelancaran pekerjaan kita ke depannya. We have now come to the end of today's program. On behalf of the organizing committee, we sincerely apologize for any shortcomings that may have occurred during the course of this webinar. We truly hope that today's event has provided valuable insights and will contribute to the improvement and success of our work in the future. Akhir kata kami ucapkan, wabillahi taufik wal hidayah. Wassalamualaikum warahmatullahi wabarakatuh.